Assalamu alaikum. This is Mr. Qutaiba, the chemistry teacher. I have experience of 7 years teaching chemistry. I taught private students for about 8 years. I'm expert in teaching international schools. All my experience was teaching chemistry in English language, so I never taught chemistry in the class in Arabic. I taught both American and British curriculums. I have experience in teaching IG system and the AP for the American system. Mainly, I taught the students to be prepared for the SAT exams in grade 12, but I had just like slightly experience in teaching the IB, which is the International Bachelor. Okay. Mainly, I'll teach SSM basis only in this lecture. It's gonna be good experience if you study SSM basis from your textbook. Better to have the summary from my lecture. So let's move on. This chapter will cover 4 sections. The first section is called Introduction to SSM basis, which goes mainly around three objectives. It will talk about physical and chemical properties of both acids and bases. We're going to know some solutions to be classified as acids or bases, plus a neutral like water. We are going to study some examples like HCl, NaOH, and so on. The last objective of lesson 1 to compare between both Arrhenius and Bronsted-Lowry concepts. We have some books that talk about Lewis model. Some of them do not cover the Lewis model of acids and bases. So it depends on your curriculum. It depends on the chapter content that you will have in your exam. I'm going to cover everything in this chapter. Whatever is cancelled in your textbook, do not go through it. We have some keywords. I'll not go through them. In the second section, we will have a brief content about the strength of both acids and bases. We will talk about what are acids that are weak, what are the bases that are weak, and how to relate the acids and bases together. If they are weak acids or bases, there is something in common in both acids and bases that are weak, and there is also similarities between the strong acids and bases. We have what do we call it, conjugate acids and conjugate bases. So we will compare the strength of weak acid with the strength of its conjugate base, which is what do we see later on. We will call it strong base. Then we are going to explain the relationship between the strength of acids and bases and the values of their ionization constants. These are going to be called K and Kb. The Ka is the one that relates to acids. Kb, from its name, relates to bases. And these are related to the K equilibrium, or what do we call it, the equilibrium constants. So because acids and bases are going through double-sided, or what do we call it, equilibrium or reversible reactions, we will see that it follows the K and Kb concepts. The third section talks about hydrogen ions and pH. Hydrogen ions are the H positive. Let me show you the H positive ions. In this lesson, we will talk about three things: the Kw mainly, and then we will talk about pH and pOH. So In lesson 3, we are going to cover H3O positive or H positive ions and how are these related to the pH and pOH. On the other hand, we are going to talk about the OH negative or hydroxide ions, how these are going to be used to calculate the pOH, or what do we call it, the scale of hydroxide ion. pH and pOH are 100% opposite to each other. pH talks about acidity, pOH talks about basicity. We can say that pH talks about how much of how much of hydronium ion or hydrogen ion found, and pOH talks about hydroxide ion content. All this is going to be covered, and we have some problems here, so prepare yourself with a calculator. We are going to use the calculator for different problems. The fifth one is like a challenge, and then we will have the last section, neutralization. We are going to know how to write the balanced chemical reaction that has both acids and bases to produce water and a salt. Then we will explain how neutralization reactions are used in acid-base titrations. You will have a new concept here called titration, and we will see how this process works. So this is more practical than theoretical. You will enjoy this lesson because it talks about the real life and how do we work on acids and bases in the chemistry lab, which is what do we call it, neutralization. From its name, neutralization means we will make solutions to be neutral. So the last objective to compare the properties of buffered and unbuffered solutions. We have some stoichiometry here, we have some calculations. We'll talk about applications of daily life like antacids. We will have a lot of diagrams that describe everything and how did we get them, how did we calculate both equivalence point and endpoint. We have a question to calculate the endpoint, and we have also some practical questions to calculate the molarity of, or what do we call it, the concentration of one of these acids or bases that are used in neutralization. We have just brief introduction here about indicators. We will not go in depth in this chapter. We will just talk about indicators. You will not memorize anything except if I assign that for you. Mainly we will talk about phenolphthalein, methyl orange. These are the most common indicators we see in students' textbooks. The universal indicator is not what do you think that it's used in chemistry. So this is like a game for students. They have the universal indicator. They put it in a beaker. They see whether this is acid or base. But the phenolphthalein and methyl orange are the real chemistry. So the acidic, neutral, and basic hydrated solutes or salts are going to be covered, plus the buffer solutions. Okay, all these are extra in some curriculums, but mainly we will go through the neutralization in this section. At the end, I will give you a summary, and there is a quiz of 10 questions, and that's it for now. If you have any questions, I'll ask you to either contact me directly or send me these in the comments. Thank you for now. Enjoy watching my chemistry videos. Thank you.